Example 9.5. The average depth of the Indian Ocean is about 3000 meter. Calculate the fractional compression of water at the bottom of the ocean. Given that the bulk modulus of water is 2.2 into 10 raised to 9 Newton per meter square, take G equal to 10 meter per second square. Now H, height of the water column, that is 3000 meter, because depth is given to you 3000 meter. Bulk modulus for the water, that is 2.2 into 10 raised to 9 Newton per meter square. G, that we have to take 10 meter per second square, and we want to calculate delta V by V. So delta V by V, that is P by B. આપણે મેગ્નિટ્યુડ વાઇઝ લઈએ છીએ એટલે અત્યારે સાઇન ને ઇમટીરિયલ કરી નાખીએ. નાઉ P, પ્રેશર. તો 3000 મીટરની હાઈટ જે વોટર કોલમની છે, તો એ બોટમ ઉપર કેટલું પ્રેશર એક્ઝર્ટ કરે. તો અત્યારે આ ઇક્વેશન યાદ રાખજો. એની લિક્વિડ કોલમ having height h exert the pressure at the bottom, that is h rho g. Next chapter માં આપણે એનું ડિટેલિંગ આવશે. So pressure exerted by the liquid column of height h at the bottom, that is h rho g. So P is replaced by h rho g. Now delta V by V, H, that is 3000, density of the water, that is 10 raised to 3, G, that is 10, and B, the bulk modulus, that is 2.2 into 10 raised to 9. Solve this one. You will get the fractional change in the volume or fractional compression of the water. Clear to all of you?